All right, welcome to the night class. Get it? Anyway, all right, we're gonna do lesson 5.7 today. We are graphing inequalities. Okay, we skipped 5.6. All 5.6 is graphing one inequality. 5.7 is graphing two inequalities at the same time. So if you can do 5.7, you can do 5.6. That's why we're skipping that one. All right. So start off with, we're not graphing at all. These should look familiar because you had these back in the very first section. They want to know, do these points satisfy this system of linear inequalities? Okay. First off, double check. Everybody knows what an inequality is, right? It's something besides an equal. All right. So this is a less than, this is a greater than, or equal to. So those are inequalities. Those are the ones we're talking about. Everybody remember those? Okay. If it's less than, you work them just like you did on our first lesson. You plug the numbers in. If it's true, it works. It has to work for how many of the equations, though? Just one of them? It has to work for both of them. Okay? If it doesn't work for both, it's not true, even though it might work for one. Everybody with me? So here is x right here. Whoa. This is my x. This is my y. All you're doing is plugging in and seeing if the inequality is true or not. All right? So what is y?
2.
No.
X.
Y is what?
3, 4, 5.
5 is less than 2 times, what is x?
3.
3. Is 5 less than 6? Is that true? That is true. That one checks out. Okay? Do the same thing with the second one. Is 5 greater than or equal to 3 plus 1? Well, is 5 greater than or equal to, what's 3 plus 1?
4.
4. Is that true?
Yes.
Yes. So this one, the answer is yes. It is a solution to that system of inequalities.
Mm-hmm.
That makes sense?
Yes, sir.
Okay. It's literally doing the same thing we were doing the other day, only we're not doing equal signs anymore. We're doing less than, greater than, less than, equal to, greater than, equal to. Okay. Part B, same process. Here's my x, here's my y. Let's plug them in. 0 is less than 2 times negative 2. Well, let's see here. What's 2 times negative 2? Negative 4. Is 0 less than negative 4? No. So I can stop right now. I don't even have to plug it into the other equation. I know it's not going to work because it doesn't work for the first one.
That's good.
Easy enough?
Yes, sir.
Okay. Let's move on to the next one. There we go. You try these two.
Whoa.
Make them a little bigger so you can see them.
Those are a little bit more complicated.
A little. I'm going to pause the video and give you the time to do it on your own, and then we'll be right back. Welcome back. Hopefully you got these done. Number 1, we'll plug in, well, it says y is less than 5 first. So what is y in our point? 5. So is 5 less than 5? No. So that one is a no. That one was nice and short. Over here, here's x, here's y. Plug them in. So we got 4 is greater than or equal to 3 times 1 plus 1.
Equals 4.
That is 4 is greater than or equal to 4. Is that true?
Yes, sir.
That one checks out. My little check marks need a little bigger tail. All right. The other one, 4 is greater than 1 minus 1. Is 4 greater than 0?
Yeah.
Yes. So
Let's go home.
1, 4 does satisfy the system of inequality, so it is an answer, a solution. Everybody good on those?
Yes, sir.
Awesome. Moving on.
Next page. Next page.
Yeah, if you flip over to 275, it's where your next example is going to be.
Did they have to come in and get their books, or are you just doing this?
Well, I'm not understand what you're asking.
Like, did your people from home come in and get their books?
Yeah, I mean, they've been here. They have their book. Oh, I see what you're saying. If you're absent and you happen not to have your book, yeah, that'd be hard.
Yeah.
All right, so we are actually physically graphing, so you'll need your graph paper this time. Okay, it says graph the system of linear inequalities. If you notice, these should look familiar, so I'm just going to have to draw my, mine. You have graph paper. If you are at home, you can do it like I am and just make your own graph paper. All right, I'm going to let this one be blue, and I'm going to let the second one be green, okay, so we can keep them straight. I know you can't do that, but I can, so I'm going to do it just so you know which one we're graphing.
Yes, sir.
What is the y-intercept on the first one?
Oh.
Say it louder, Michael. 3. Okay. Does it have a slope? It does. It's just the slope is what, though? 0, because there's no mx there. Okay. So we're going to go up 1, 2, 3. And I'm going to make my dot. Okay. And if I have a slope of 0, is that a horizontal line or is that a vertical line? It's horizontal. Okay. Next thing, you see the line under the less than? That means you draw a solid line. If there is no line under the less than, you draw a dashed line or a dotted line. Everybody with me? Okay? Now, every time you have an inequality in your graphing, you're going to have to do some kind of shading. Okay? It's very simple. If it's less than, you shade down. If it's greater than, you shade up. So this is what? Is that less than or is that greater? That is less than. Less than look kind of like an L. Okay? So you shade everything below it. Just like that. Okay? You can probably shade a little better than I can, but
just like so.
All right? The second one. What's my y-intercept on the second equation? 2, which is right there. And my slope is, what's an understood right here?
1.
1. So I go up 1 over 1. Up 1 over 1. Up 1 over 1. Or I could go down 1 and left 1 and keep going that direction.
Yeah, however you want to do it.
Okay? Notice, is there an equal to under this inequality? Do you see a line under the greater than? No. So this one you just do a dash line, or you could just leave the dots if you wanted to. Okay? So there's my line. And do I shade above that line or below that line? Above. Why? Because it is greater than. So everything above this line gets shaded. Okay? Now, if you notice, I'm not doing much shading. I'm just kind of drawing lines. Now, my answer, your final answer, is where those two shades what? Meet. So my final answer is all of this in here.
Yes, sir.
Does everybody understand that?
Yes, sir.
Okay? And I know you're probably asking, what's the point of this? We can just plug them in. You can just plug them in, but this kind of tells you what points would satisfy these equations without actually having to plug them in. Okay? Any point inside here, like that point right there. Let me make it a different color. Let's make pink. This point right here, would that be a solution to that system of inequalities?
Yes, sir.
Yes, because it's in the double shaded part. Everybody see that?
Yes, sir.
What about if I had a point here? Would that point be a solution?
No.
No. It's in the shaded part, it's just not in the shaded part where they intersect. That makes sense?
Yes, sir.
Okay. So all of these in here in the double shaded part that's your graph. And the reason I'm making sure, because a lot of times on standardized tests like ACT and stuff, they leave off this part, these parts that just shade once. They only give you the double shaded part. Does that make sense? Okay. So all you have to do on your paper, lightly shade and then lightly shade and see where the shades are crossing and then darken that part in for me. Does that make sense? Okay. Easy enough. All right. You got any questions? Okay. Easy crew. Let's see how we did. See if ours looks like theirs. Ours is pretty close, huh? They used red and blue, which made what? Purple? Okay. And they put the solution is in the purple shaded range. All right, so they used -3,1. Is that the only answer that works? Nope. Any point in that purple part works, just like we just had. Any questions? Everybody good? All right, let's move on to our next one. Let's skip that one and go to the example 3 here. Uh-oh. Well. Maybe it's taking too long. There we go. I want to do one more. Well, they already graphed it for us. Oh well.
What are these corn dog heads?
What were they thinking? All right. So they graphed these for us, which is fine. I'm gonna erase that real quick. Tell you what. Well, I'll just go over there. So they let this top one right here. That's the blue one. Okay. Whoa. Excuse me. So they did this one in blue and this one in red. Now I know they've already graphed it for us over there, but what would we have had to do first in order to graph these? Solve it for what? The slope, which means we got to get what by itself? Y. So this blue one here, okay, I would move that 2x over and it would become y is less than -2x minus 1. And that red one would become y is less than -2, or excuse me, not less than, greater than -2x plus 3. Everybody see that? Okay. And so what they did is they, on the blue one, what's my y-intercept? -1. Come over here. You make a dot at -1. Your slope is down 2, right 1. Down 2, right 1. You make another dot, down 2, right 1. Or you could go up 2, left 1. Up 2, left 1, up 2, left 1. And then you make your dashed line. Okay? They shaded below that. Should they have? What's my sign?
Less than.
Less than, and less than you shade what? Down. Okay? Did they shade down? Yes. Yeah. For the red one, the second equation, you start at 3, and its slope was also -2. So again, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, the whole way. Notice, both of these lines are dotted because it's just less than and just greater than. It's not equal to. Everybody with me? Greater than, I shade where? Up. That is my answer. So what is my answer? No solution. Because the shades do not what? They do not intersect. Okay? So what that means is there any point anywhere that would satisfy both of these at the same time? No. Okay? It might satisfy one or it might satisfy the other, or it might not satisfy any of them, but you don't have a point that will satisfy both of them at the same time. Any questions? Everybody good? All right. We have one more that I want us to do. We're at 15 minutes. We're doing pretty good. All right. So, just to show you, a system has no solution, just like we got. Sometimes they're going to make you work backwards. Let's see if I can find which example I'm looking at here. Example 4. Example 4 is what I'm looking at. And then after we do this, we'll call it a day, and I'll let you get to work on some of your homework problems.
From yesterday or from today?
From today. Connection was reset. Well, my connection has not been the greatest here. Come on. No, that's not what I want to do. All right. So you'll know that you really know something when you can do it backwards and forwards. Okay? So what they're asking you to do here, they've given you a graph, and they want you to make the inequality, the system of inequalities. Normally, they give you the system, and you have to graph them, right? Well, you're working backwards. Everybody with me? It does not matter which order you put your inequalities. Everybody hear that? Doesn't matter. You can put whichever one you want to do first, all right? I'm going to start with this line right here, okay? What inequality would make that line right there? Well, first of all, it's horizontal, so I know it's going to be just y and some number. There's not going to be an x. Everybody with me? What is my y-intercept? Where am I crossing the y-axis? Well, here's the origin right here. I'm crossing the y-axis right there. Where is that? 2 where? -2, because it's 2 down. So I know it's also shaded where in comparison to this line? Up. So it's greater than. Is it equal to? Yes. It's a straight, but it's also what kind of line? It's a solid line. Okay? Every time it's a solid line, there's an equal to. What is y greater than or equal to? What's my y-intercept? -2. That's that line. All right? Now we have to do the same thing for the dotted line. So it's the blue one. So we're going to have y. Am I shaded above that dotted line or below it? Below it. So it's what? It's less than. Is it equal to? No, because it's what kind of line? It's dotted, dashed. All right. What's my y-intercept? Where it's 0, and my slope, I may have to find another point or two. It looks like I'm just going what? Up 1, where? Right 1. Up 1, right 1. Up 1, right 1. Well, that slope, that's just 1 over 1, which is what? 1. So my slope is just 1x. Do I have to put +0? No. You can if you want, but this just simplifies to y is less than x. Any question? Any questions? Excuse me. Any equations? Any questions? Everybody's good?
Yes, sir.
All right. Let's try one more of these. That's all of that, and then I'll let you get started on your homework. Oh goodness. There we go. You do that one. Again, I'll give you a few seconds to work it on your own, and then we'll be right back. All right. So this line right here. Again, it's a horizontal line, so my slope is going to be 0. It's just going to be y. I'm shaded below it. So will that be less than or greater than? That's less than. Is it equal to? Yes, because it's solid. Okay. What is it less than or equal to? Well, what's my y-intercept here? What is that point? 2. Y is less than or equal to 2. All right. My dotted line here goes through that y-intercept. So that's going to be y. Am I shaded above or below? Above, so it's greater. Okay. It is a dotted line, so no line under it. Okay, it's not equal to, it's just greater than. What is my slope? Down 1, right 1, down 1, right 1. So that's down 1 would be -1 over 1, -1. So that's -1x. And what is my y-intercept? 1. So plus 1. There are my system of inequalities.
Beautiful, coach.
Everybody good? All right. I hope this video helps you at home, and as always, stay above the line.